welcome to my channel. So last class we discussed some numerical problems from the lesson electrochemistry. So today we are going to do some more problems from the electrochemistry. Last class we have done the solved examples in the NCERT. Today we are going to in-text questions which are not solved. So the first question, again I'm repeating, when those who have not learned the formulas, that like Nernst equation, relation between Nernst equation and or the relation between electrode potential and equilibrium constant, relation between Gibbs free energy and the equilibrium constant, please note it down, then only we can write all this reaction. And you should know about what is hydrogen electrode and what is the reaction or what reaction is taking place in hydrogen electrode. If we are thorough with all this, then we can easily do the problem. Okay. So the first question, that is calculate the potential of hydrogen electrode. Calculate the potential of hydrogen electrode in contact with a solution whose pH is 10. What is given there? We have to determine the potential. We know that what is potential? E is that we have to determine. Whose is a hydrogen electrode which is in contact with a solution whose pH is 10. pH is given. It is 10. Okay, so what the pH has to do in this equation? So we know that E cell is equal to E0 cell minus 0.0591 by N log oxidized state divided by reduced state. So this was our Nernst equation. Those who don't know, please refer the video that what is Nernst equation, and then only you will be able to do this step, or you will be able to understand why I wrote here oxidation and reduction. So we should know what is the reaction taking place in hydrogen electrode. Hydrogen electrode. We know the reaction that is taking place in hydrogen electrode is H plus 1 electron gives half H2. This is the reaction which is taking place in hydrogen electrode. And we all know that E0 standard electrode potential of hydrogen electrode is 0. That is SHE, you remember. Standard hydrogen electrode, its value is E0 cell is arbitrarily found to be 0. We know to write the Nernst equation. E cell is equal to E0 cell minus 0.0591 by N. You remember that is to RT by NF, ln, and we are substituting all those values here, and we will be getting 0.0591 by N log. What we have to write here? We know that Nernst has derived equation Mn plus n electron gives n. Then E cell is equal to E0 cell minus RT by NF log or ln M divided by Mn plus. We know that the concentration of metal has been taken as unity. The same like we will be getting 1 divided by, that's the product divided by reactant, that is equal to H plus. This is log H plus. So we know that is 0 and this is 0.0591 by N log 1 by H plus concentration. From where we'll get the H plus concentration? Because in the question they have not given any H plus, but they have given one value, pH. What is pH? We have learned pH is negative logarithm or the negative base term of hydrogen ion concentration. So from here H plus we will be getting. We know pH is equal to 10. That is minus logarithm to the base 10 of H plus. So we can write this like this. You have already learned this. That is H plus concentration will be 10 to the power of minus 10. How I got this? I can write minus 10 is equal to log to the base 10 H plus. So this log has to be taken here and it will be like base 10. So 10 raised to minus 10 will be the concentration of H plus. So 10 is equal to minus log base to the 10. We know that the pH is the negative logarithm of hydrogen and constant, negative logarithm of base 10. Base 10 logarithm of H plus and concentration or minus 10. How we get this? There is a formula like this. If y is equal to log A into x, then x is equal to A raised to y. The same thing I have done. That is here, that is 10 is equal to minus log. So what I have done? Minus 10 is equal to log base to the 10 H plus I. Then what I have did? which is the base logarithm that has to be raised, that is a raised to y instead of that 10 raised to minus 10 I have written. I think these all you have learned in your mathematics and all. So I can write the concentration of H plus as minus 10 raised to minus 10. 10 raised to minus 10. So it is easy. That is minus 0.0591 by 1 because n is 1 electron. Log 1 by 10 raised to minus 10. What is 1 by 10 raised to minus 10? I can write like this. 10 raised to 10. Log 10 raised to 10 is 0.591 by 1 into 1. We don't want to. It is 10. It will be 0.591. Easel. Easel is, don't forget this minus, it is minus 0.591. Clear? Only the confusion word, it will be little bit confusion, pH. pH is given. So pH is negative logarithm of hydrogen ion concentration. So 10 is equal to minus log, that is base 10 logarithm, okay? Minus log to the base 10 H plus. So what we have to do it, we can write this is minus 10 is equal to log to the base 10 of H plus. To determine H plus, we will write 10 raised to minus 10 is equal to H plus. So that we can substitute here and we will be getting the answer. Clear? So the next question, the same question we have done in our previous video. It's a direct application. So I think no more detailed explanation is needed for this question. What we have to do? Calculate the EMF of the cell in which the following reaction takes place. We have to directly determine the EMF, that is E cell. Calculate the EMF of this cell. Either we have to E0 cell is given, okay? E0 cell is given as 1.05 volt, okay? So we have to determine E cell. We know the announced equation E0 cell minus 0.0591 by n log oxidized state divided by reduced state, okay? Or we can write the product divided by the reactant, okay? So E0 cell is given, that is for 1.05 minus 0.0591 by n. We have to determine the number of electron. So many can easily know that what is the number of electrons. Those who don't know, again I am just repeating. Here which is undergoing oxidation, Ni. So Ni2 plus 2 electron. Who is undergoing reduction? Ag. Ag plus 1 electron gives Ag. So we know that we have to balance it. The number of electrons, we are multiplying this equation with 2. So it will be 2Ag plus 2 electron gives 2Ag. So whenever we are writing a cell reaction, the electron number should be same. So the electron number now is same. So it is 2 log, which is undergoing oxidation, Ni2 plus. So it is the concentration of Ni2 plus is given as 0.160 divided by Ag. Ag plus means the value of Ag is 0.002. We cannot write it simply like this because there is a stoichiometric coefficient for 2, that is should be raised. So by doing this mathematical part, you have to do it and the answer will be 0.915 mole. Direct application. If the question is like this, represent the cell for this reaction, what you have to do? We know that a salt bridge, here it will be the oxidation and this will be the reduction half. So we have to write the oxidation half. We know what is undergone oxidation. So Ni bar, Ni2 plus double bar. Ni is solid, Ni2 plus it is 0.160 molar concentration, and that one is Ag plus bar Ag. The concentration of Ag plus is given as. So this is the cell representation for this reaction. Clear? So I think we have done some of the important problems which is given inside the textbook. And the third one is very simple, all the direct application. Please try to do that. So the remaining questions we will be doing in the next class. Okay, thank you.